Bristol Community College, Mathematics with Dan Avedikian, Math 131, Elements of College Mathematics, Section 3.1, Problem 9. This is Section 3.1, Problem 9. It says, graph the linear inequality x is less than or equal to 3y. So this one is a little bit different than some of the others we've done, but the same four-step process will work. First, I'm just going to pretend it's x equals 3y and find 2 points that make the equation x equals 3y true. So to do that, for step 1, I'm going to make a little chart next to the linear inequality that I have to graph with an x column and a y column. So the first thing I usually do is let x equal 0 and solve for y. If x is 0, and I'm pretending this is equals, I have 0 equals 3 times y. Well, y would have to be 0. So 0 equals 3 times 0 would make 0 equals 0. So if x is 0, y would have to be 0 to make the inequality true if I'm pretending it's an equation. Now, here's where it gets a little bit different. Usually what I do is now I let y equal 0 and find the value of x that would make the inequality true if I pretend it's an equation. But I'm going to get the same point again, 0, 0. I need 2 points to graph the straight line. I can't graph 0, 0 and then 0, 0 again. They're both in the same spot. I wouldn't know what to connect with the ruler. So I have to find something else. And I had mentioned a few times that you don't have to use 0. So here's a situation where we're going to pick something else. So I'm pretending I have x equals 3y. I want an x and y value that makes that equation true. And you can pick all sorts of values. You can use fractions, negatives, positives. One that works very easily, the first one that comes to my mind, is if I let y equal 1, 3 times 1, x would have to be 3. If y is 1 and x is 3, I would have 3 equals 3 when I pretend I have an equation. So I do have 2 points that makes the inequality true if I pretend it's an equation. One of them is 0, 0, x is 0, y is 0, and the other one is 3, 1, x is 3, y is 1. So now on to step 2, plot the 2 points from step 1 on a graph. And I have a graph ready to go. One point is 0, 0, the origin, so over 0, up 0, so right there. And the other one is 3, 1, so I'm going to go over 3, up 1, so if I do that, that's 3, 1. So I have 0, 0, and 3, 1. I plotted the 2 points on the graph. That's step 2. Step 3, connect the 2 points with a straight line. And I have a ruler. I'm going to put it on the 2 points, connect them. Before I do that, I will notice that I have the or equal to in my inequality symbol. So this was going to be a solid line for this problem. So there's my straight line. I smudged it a little bit. Now I have to decide whether I shade above the line or below the line. Now I usually say choose a test point that's not on the line, use 0, 0 if you can. Now my favorite test point of 0, 0 is on the line, so I have to choose a different test point. So I have to choose something that's not on the line. Let's say go over 2 and up 2. So my test point is going to be the point 2, 2. So I'm in the up above portion right here with 2, 2. I'm going to put in a 2 for x, 2 for y, and I'm going to see if the result I get in my inequality is true or false. So if x is 2 and y is 2, 3y becomes 3 times 2, I have the result 2 is less than or equal to 6. That's certainly true. 2 is less than 6. That's a true statement. So my test point is on the up above side. The result I got was true, so that's the side that I shade, the above side. So everything in the above side gets shaded. Now, had I picked, say, over 5 up 0, I should get a result that's blank, that's false, and that would make it the blank side. So I'd have 5 is smaller than 0 if I put in 5, 0. Not true. So it works. You can pick anything that's not on the line. I happen to pick 2, 2.